Hi everyone, welcome to this newest video. My name is Johan and today with me is Huib Dijkstra, a EUC Sales Specialist from VMware. And today we want to explain you something about the application delivery models included in Horizon 7 Enterprise. So Huib, you already drew part of an infrastructure here. Could you explain something about this drawing?
Yeah, sure. I kind of want to use today to to dive into my favorite solution setup. It's mostly the jump concept.
So that's the just-in-time management platform, right?
Exactly, it's a just-in-time management platform. It consists out of three things. It's the Horizon 7 instant clones, it's app stacks by app volumes, and user environment management by VMware. So,
okay.
I kind of already drew out the instant clone piece onto the board. It consists out of a couple of steps to generate your pools. Firstly, you're going to create your master VM, your golden image, but most importantly, you're going to create a master VM snapshot.
Right.
That's your base starting point. And preferably, you want to do this automated using some sort of task sequence.
Okay.
So you can go back when you make a mistake.
And especially, for instance, with Windows 10, which comes with a lot of updates.
Yeah.
You want to automate that update sequence and automatically create those snapshots as well, right?
Yeah. So you can always retrace your steps.
Right.
And you can find out how you got the error or how you got the mishap into your template.
Right.
So, and then really the first step within Horizon is to create an internal template. So it is a template, it's kind of like a linked clone, it links the template to your master VM. So and that's where our pool journey begins, because as soon as we click the wizard for generating a pool or creating a pool using instant clones, first step is that we're going to create a replica. The replica is going to sit onto the data store. If you have multiple sites, it's going to sit on every data store you have if you span the VMs across multiple sites. And it sits there because all the ESX hosts need to be able to have access to that file. So, and when we've selected all the ESX hosts on which we want to run the VMs or the VDI pools, we're going to generate a parent. So the parent is a running VM in memory that we're going to use to basically fork using the VM fork mechanism that is available in vSphere.
Right, and forking or creating a clone, such as an instant clone VM, takes like 10 seconds, right? So it's hence the name instant clones.
Yeah, so it's actually even faster than that. It's about a second to create the VM itself.
Wow.
There is a post-prep phase, so to prep the VM for use, because when we clone the machine, it's exactly the same as the parent. So same name, same everything. So there is a process that will make the machine unique, but the generation of the VM itself, it's between 1 and 2 seconds.
Wow.
So it's super fast. So, and because the machine the parent is in memory and is already running, we don't need to boot all these machines.
Right, so that saves you a lot in terms of boot storms.
Yeah, exactly. It saves you a lot of I/O, a lot of CPU, and also in disaster recovery. So when something does go wrong, you're very quickly back up and running. So
right, and I can imagine that, take the era of link clones. If you wanted to update, let's say 1,000 link clones, you had to do that during maintenance windows, at night and stuff. But that works differently here as well, right?
Yeah, sure. Yeah, I can even go as far as advising to do your updates midday.
Really?
Because when you're in a maintenance window, you usually have like 2 or 3 IT engineers on site. Well, if something goes wrong, you often need multiple guys to fix the problem. Maybe your colleague that is at home knows what the issue is. So with the parent running in memory and with instant clones, because we're not using any resources to redeploy a pool or to update a pool, you could choose to do this midday.
Wow.
While all your IT engineers are available to help out when something is not going as well or is not going as planned.
Right, so and you left here one open.
Yeah, I left one open.
Right.
It's kind of a bridge to our next step. So I'm going to use a different color. So I kind of want to zoom in onto this VM. So that's like zooming in, not zoom the application. Yeah. So because I want to talk about app volumes. So looking at this VM, we're going to have the operating system. So
that could either be like Windows 10, Windows 7.
Yeah, so that's actually still the Horizon 7 bit. It's a VMDK file which is created by the instant clone process. But the app stacks that are going to be created by volumes are going to sit on top. So you can have multiple app stacks. So let's draw out 2 here. And these are read-only VMDK files.
And every app stack could contain multiple applications, right?
Exactly. You can host multiple applications within one app stack. So, and actually what the volumes does is it merges all of these elements into one C drive. So this is all going to be just one normal C drive. So if you install applications in an app stack and you look at the result as an end user, you're just going to find your applications in program files and folders in your HKey current user. All files will be at the place that they would normally be at, so no sandboxing or anything. So while this is application virtualization, it doesn't do isolation.
Right.
So these app stacks, the applications inside these app stacks can find each other. And also the OS is going to find the application. So this is going to mean a lot of your the number of successful applications that you can virtualize. So the ratio in which you can virtualize application onto application that you can't, because the application is in the normal spot and the OS can find the application. We're seeing that a lot of applications that in the past we couldn't virtualize, we now can because the new way of virtualizing applications. So that's a huge benefit, and it's also going to mean a lot in cost because it's going to speed up your application packaging.
Right.
Because you don't have to go back and forth finding out which bits don't work and which bits do. We're seeing that it's I'm not going to say next finish, but it's close to that.
And they'll perform really good as well because I'm assuming it right that they live on a data store, right?
Yeah, exactly.
Next
so
to the VM.
We can draw them on here. So it's A and B. So they're next to the disk of the VM onto the data store, and assuming that you have the right I/O capacity, they are going to perform really, really well. Yeah.
And because they live on a data store, it's a one-to-many.
It's one-to-many, exactly. So
connectivity. So one app stack could be connected towards many desktops,
yeah,
right?
up to 2,000 hosts.
Wow.
Yeah. So so again, these are read-only, so users can't break them, and all these users in these 12 VMs we drew on the board are all going to share the same 2 app stacks that are sitting on the data store.
Right. So you were able to customize those applications as well, right?
Yes, you can capture settings and customize the application during the capture, or we could separate the two and place the settings in a different layer. So, and actually that I prefer to use that method. So I'm going to draw out another component by VMware. It's called User Environment Manager. And it basically does 2 things. It's a rich set of tools for setting up the environment for the user. So screensaver, start menu, all that kind of stuff. Printers, drive mappings. And it saves the user profile. And it does it in such a way that it creates tiny zip files. So for example, if I have 3 applications in AppStack A, the setting of those applications that a user generates are going to be placed in little zip files.
So every application will get its own zip file.
Yeah, exactly. So if something breaks, you can reset the settings for that specific application and not destroy the user's day by resetting all their settings.
And it's just the bare minimum that's required for that customization that's saved in the zip file, right?
Yeah.
Right, okay.
So we tend to leave a lot of cookies and large cache files out.
Right, okay.
So
and that makes the profile really agile and quick to load, right?
Yeah, exactly. So it's quick upon quick upon quick.
Right.
So, but that's just the user-generated settings. We were talking about settings for the application itself, usually that the application owner defines. So we can preload those settings using a process called app capture, app profiling. I'm going to talk about app capture a little bit later. And what you can do with app profiling is you're going to run the application profiler from UVM, and you're going to start up your application, and you're going to ask your application owner to sit beside you and set up the application as he would normally do. So disable auto startup, set certain type of language files, set certain type of settings. All those settings he can do during the application profiling. And when he's done, we're going to create a set called predefined settings.
So that could be like a Dutch language or an English language or French that you create in a separate settings file?
Yeah,
right.
Exactly. So you can use conditions for that.
Like I'm part of an OU or a...
Exactly, or
AD
part
group?
of a group that defines that I'm a Dutch user, and hence I get the Dutch app settings file, predefined settings file. So this way we can set the settings outside of the app stack, which makes, well, like I said, it's not really next finish, but it really comes close to that. And talking about app stack creation, we haven't talked about this process. I already mentioned the name. That's called app capture. And it's a lot of like the other virtualization tools. You're going to start a process which connects a writable app stack to your packaging machine, and you can install one or more applications. You can do as many reboots as you want. You can even use task sequences to deploy your applications in an app stack. That way you have everything automated. So you got the master VM automated and the applications as well.
That would be your best practice to do that, right?
Yeah, preferably. Typically in larger environments where you have, like for example, the Adobe Reader, you're going to have it in multiple app stacks. It's wise to have an automated way, so there's no difference between the two app stacks in settings or installation. So when you're using these tools together, there's actually a really neat trick you can do when creating app stacks. So for example, I have a front-end, back-end application. So there's the front-end application that connects to a back-end database server. But I'm using a test, acceptance, and a production environment, and I've also got 3 or 4 different user groups within my organization that are using this application, all having a different database. So what you can do is you can use placeholders. And it's actually a technique from UVM, but you're going to use it within the app stack. And it has a specific syntax. You have a bracket. You're going to write down flex. You have a hash, and then closing a bracket. And between the hash and the closing bracket, I can put any variable I want. So these can be your existing system variables, but like I said before, the user environment manager can also place environment settings onto the desktop. So you can create custom variables. So this way, again, using conditions, I can set a variable, for example, if the VDI is booted in an OU called test, that it was going to fill into this syntax the test database server.
Right.
So I can use this in a registry file or an INI file from the application. So
in that way you could consolidate even more app stacks, right?
Yeah, exactly. So I call them in my own term universal app stacks. You're going to have an app stack that you can connect to test, acceptance, production, or use for one of the 3 or 4 user groups within your organization.
Right.
All without having to change the package one time. You can every time use the same package. You're going to just use different kind of predefined settings together with placeholders. So this is for the most part how I set up managed applications. So we skipped over one requirement, a requirement I'm seeing more and more often, that companies do want to have the non-persistent machines because of the speed and control it gives them, but the users still are asking for a way to customize even further by, for example, installing their own apps. And we can do this within this setup. So we're going to add another layer. And the layer is called the writable volume.
And that's provided by app volumes as well, right?
Yeah, so I'm
Right.
still writing in yellow here. So actually I need to extend this because it's also going to be merged into that one C drive as a result. So
this one is one-to-one linked, right? So
This
every
is-
user
yeah.
has their own writable volume. Okay.
Exactly. So this is one-to-one linked, and you can define the scope. And within this setup, I would go for everything that's managed is managed throughout the different components we talked about before, and everything that's unmanaged, hence the user-installed apps and the settings that go with those apps, place them in the writable volume. So this is my favorite setup when we're looking at Horizon 7 app delivery. It gives you control, it keeps down costs, and it does give you a lot of functionality for the end user. So
Great.
I think this is a perfect setup.
Awesome. Okay, guys, thanks for watching. If you have a question about the delivery model or Horizon 7, drop us an email. That's Huib's email address. This is mine. Thanks for watching. See you next time.